So I just want to explain a bit about levers. Now this lever, I'm putting 1 kilogram 4 pegs along on the right hand side, and it obviously doesn't balance. I'm going to try and make it balance by putting a 1 kilo 2 pegs along, and of course that doesn't balance. But if I put 2 kilos 2 pegs along, I can make it balance. Now this is a wheel on a mass mover, and it also is a type of lever, and I'm just going to explain how. So we've got a mass of 140 grams, and the radius of the axle is 5, so that equals 700. And on the other side we've got just a 10 kilo mass, and it's 70 away from the center, so that also equals 700, and hence it balances. When I take the mass off, it stops balancing. Okay, this system, it doesn't balance, yet I've still got the same masses. I've got 10 on the left and 140 on the right. The thing I've changed is the radius of the axle. It's now 10, and you can actually do the maths and try and predict what you need to put on the left hand side to make it balance. So if I add another 10, that will give me 20 times 70. Now this is the third system. In this case we've got a radius of 16. The mass is 130 grams, and that balances with a 30 gram mass at a distance of 70. And so these three wheels that I've just shown you illustrate how a lever works, and the result is that every time we increase the radius of the axle, the amount of force that's produced at the outside of the wheel increases, which means that your vehicle's going to go faster. However, there's a downside to it, which we're going to have a look at in the next bit of the video. So how does all this relate to the mass mover? Well, here's one going. There's a mass falling, and it's unwinding the string. And as you can see, I've marked it with 2 orange marks, the start and the finish, to see how far the mass has moved downwards. At the same time, I've marked the wheel, and with 1 revolution, the vehicle goes 45 centimeters. At the same time, the mass fell about 32 millimeters, so we can do some calculations. Okay, so this is a real mass mover. There's the pulley. And remember, it was this one, the second one. There's a radius 10 millimeters. So let's have a look at how far the vehicle goes. So not surprisingly, it goes exactly the same distance because it's the same wheel. But look how much of the string it's used. So it's unwound considerably more. So if you want your vehicle to go like this, or more like this, but the downside is that the mass would have to fall twice as far for the vehicle to go the same distance down the track.